I guess Jennifer was not added as a panelist. Let's see.
I can invite her right now if that's.
Yeah, that would be great.
Let me get her Gmail, I believe.
Yeah.
Yeah, let me. 1 second.
Oh, here we go. Can also.
I think I did this correctly. Maybe.
Yeah.
Let me double check. Should we stop the webinar for now?
Is there a way that I can pause it?
I'm not totally sure. Give me one.
Hope everyone can see my screen now. And so today I'm going to talk about our team, which is the applied scientist team in AWS, and what's our mission, and 2 of the recent projects we have been done with the customers to see how we are going to not only prototype a machine learning model, but also help the customer to consider about the production plan. I think, yeah, this is about today. Yeah, so I will start with an introduction and how we are working backwards with our customer to tackle the real life use case. And then I'm talking about the first use case is in the auto manufacturing industry, and how we are going to use machine learning to personalize in-vehicle thermal comfort. And the second project I would like to talk about is also a very interesting project that about how to use machine learning and NLP to do intelligent financial document understanding. I think we will have a Q&A at the end, or I think if you have any question, feel free to type in the Q&A window. And because I cannot see the window right now, but if I will take a break and ask if any questions, and Diane can help. Cool. So starting from machine learning, we know that machine learning has been a lot of progress recently, and we have a lot of new algorithms coming out, new models, and so on. And but still, it's very hard for many organizations to actually put the machine learning or the models into their operation or production. So when we talk about AWS have been work with many customers, and our team also work with many customers. And based on our experience, we noticed that there are several areas customers usually feel like it's so hard to put machine learning into action. Number one is that they cannot find the best use case that actually can be developed and into production. Number two is that the customer may not have the right skill sets, people that can start the transition from a non-machine learning operation to a machine learning operation. Number three, we know data. A lot of customers say, oh, we have a lot of data, but those data may not be ready for machine learning or building any models. So the data strategy is also something a lot of organizations needs to figure out before they can do something into machine learning production. And also some companies also have all of this combination. So that makes them really wants to try machine learning. However, they do not know where to start. So this is where our team, AWS Machine Learning Solutions Lab, coming from. So with AWS 20 years machine learning experience, and they established this team basically to do two things. One is to earn trust for the customer, to help them identify the use case to start the machine learning journey. And the second thing is that actually help them to adopt machine learning into their operation, or accelerated, if they already start, accelerated them to a more to the current state of the machine learning status. So this is the goal of our team. So as you see, how we are going to work with this. Our team is a global team, so we have members from the North America, from Asia, and also from Europe. And we have been working on different domains. How we look at a machine learning use case, we normally look at that in two dimensions. The first dimension is more related to machine learning domains, for example, like fraud detection. And the second dimension is we call verticals. It's like the industry or the special type of industry knowledge and use cases. So when we see these two dimensions, we found out we tend to think about the best use case for machine learning is actually the cross of these two dimensions. So that this is where we try to identify the use case with the customer to start the journey. This is just some customer have been working with AWS AI to work with some machine learning pilots or production. So today, nowadays, based on this experience, we summarize and come up with a developer approach, how we are going to work with industry customers. So like you said, there's multiple methods. Honestly, not every customer need all the methods. Some customer maybe just needs some of those methods to get started. I will just quickly talk about a couple of them. The first one, normally what we do is working backward from a business use case. So we normally start with a diagnostic call with their business sponsor to discuss about their pain points and what do they see they want to solve and give them the best value. And then if there is, we identify machine learning probable candidate use case candidates, we will go for a half a day discovery workshop. In this case, not only with their business sponsors, but also with their SMEs and their business teams and engineers teams, even data science teams and so on. So in this workshop, the idea is to formulate as many as use cases as possible, but prioritize them based on the readiness and also the value. The readiness, including the data readiness and also production readiness and so on. And value is that how much impacts you will bring to the company, right? So if the company really wants to us to proof of concept, so some company will go into the third stage to do a POC with us. So we are partner with companies. Usually it's the data team, engineer team, or data science team, but also take the questions inputs from the business team to develop the model that actually showcase, okay, we can use this model to solve this problem and how much accuracy we improve compared to the baseline without a model, right? So this is normally takes 8 to 16 weeks. And it's very similar, I think, for like the projects you have been done in practicum and so on. The idea is to show the values and show it's feasible and how good it is, right? Your model approach. Once it's done, normally we see two paths. Customer take it into production. Now, one path is that the customer's engineers team, they can take the model into production, and we already have AWS have a lot of like guidelines, steps, or templates for them to maintain the model, deploy the model, and so on. And another way, they also can work with some other AWS team to basically put into production. So the idea is that instead of have the customer there all by themselves or give them something we built, we want to let the customer learning, get the machine learning education, as well as know how to fishing instead of to give them the fish. This one is just quickly. So in some case, the company even needs some machine learning training or education. We do have some kind of program, especially for their leadership. This is because when we find out normally whether a use case can go to production, the most important thing is actually more from top down. If the top business sponsors are more aligned and more aware and support for machine learning, it's more likely that this is going to go to production. Okay, so just quickly how this is the public AWS ML stack. So basically the way we think about AWS AI is 3 levels. You can think about the first level AI services is like pre-trained models. For example, like a recognition or transcription. This is for those people who do not need to know about machine learning. For example, like a web developer or something, app developer. So they can directly plug in those pre-trained model API and then build their application. And most of the time when we are working with the customized model with the customer's use case, we go from the middle layer called machine learning services. All this is in the platform called SageMaker, Amazon SageMaker. It included the way you can label your data, you can experiment on your notebook, and even go all the way to you can basically host your model there easily with what kind of CPU, GPU, how many endpoints you want. We do also have something like you may know that some researcher, scientists, or just researchers, they need something even deeper. As AWS, we also provide some kind of framework and infrastructure so that they can easily, for example, pick their GPU instance and so on. But this is more for those machine learning experts who wants to do deeper research and so on. So a lot of time when we are working with the customer, we are more focused on the middle, how we are going to build a customized model for their use case. Yeah. So I will pause here a little bit before to the second session to see if any questions. Okay. If no, I will go into the first use case I want to share today. So this is the use case about how we are going to use machine learning to smartly control the thermal comfort in the car. So this is this work is done with German auto manufacturing company called Continental AG, and it is a company working with a lot of big German company auto manufacturers. So the request or the feedback they get from their customer is that a lot of car drivers, they actually, when they are trying to, when they are driving, they also need to adjust the temperature settings from time to time. Although nowadays there is a manual, there is auto, but even with the auto setting, they still have a lot of situation they need to adjust that. For example, if they change the clothes, for example, passenger changing the clothes, or if the sun coming out, or the sun is covered by the cloud and so on. So you can see there is a lot of situation that is very personalized. So different people, even the same temperature setting, the driver and the passenger one, passenger two, they may not have the same feeling like it's comfortable. This is also due to the sensitivity to the temperature, right? So the business question is that if we could have a new mode instead of auto, maybe it's a smart or AI or ML mode, that could help the car to basically learn individual preference and automatically make those adjustment for each passenger. This will be save a lot of, especially for the driver, to the distraction and make it more comfortable when they were driving. So in order to tackle this problem, we do work we work with the customers, SMEs and data science team and engineers team, to try to first formulate this problem into a problem that with different variables, as I will explain a little bit, and how we think about the dynamic system. And then we could, from here, we could propose a data collection plan with the customer. So let me start from the top left corner. First thing you can think about, we'll decide the in-car temperature. Probably is the sun level and also the set temperature the driver set. However, when the cabin temperature is defined, actually for individuals, what is more important is the near skin temperature, basically how they feel, right? The temperature. So this also depends on at least some other factors, including clothing, and also including the personal factors, for example, the metabolic rate and so on. So all of this will basically decide the near skin temperature for a passenger or a driver. However, even with the temperature, different people still feel like a different level of comfort. For example, some people are more sensitive to cold, or some people prefer something, for example, even a cooler temperature and so on. So all this kind of personal factor together with the near skin temperature will basically decide about the comfort level for an individual, right? So when the comfort level is good, okay, that's okay. That probably go to a relatively platinum, right? However, when the comfort level is not that good, too hot, too cold, a little hot, little cold, the user will adjust the set temperature and then go through the circle again. You can see this is I color code different type of the things. The green one is the box, basically it's the personalization factor, right? Personal factor. We probably cannot directly collect data on this, but we could basically using individuals data to basically to learn for each person. And the orange coding, like you see, this is something actually is like a external variable. So the sum may change when you are, especially when you are driving on the highway, the weather can change, and you are in different region, the weather can be different. And the clothing is also something can change when the person, when the people someday they probably needs to wear something, wear a lot because of work or something. Sometimes they don't have that, they just wear very casual or something. So these two are external factors that we could actually measure, right? And all these blue things are decided basically by other factors, and they are also have the interdependency. So what we are trying to do is that instead of the user adjust the set temperature, yeah, let's just train a model which is like it's an AI, right? To basically using the previous data to predict, okay, whether the user will increase the temperature, decrease, or no change. So this is more like a simulation situation. And once we set out these dynamics, then we can simulate the data to build a model, proof of the concept. And once this is what we do. So we try some different approach first with the simulation data based on our proposed theory, dynamics. We try several approach, and it turns out the best model is actually a contextual and personalized model. What does it mean? So that means that in order to learn from the data, the best model actually first will have a want to leverage the commonalities across users, but the model also needs to learn the difference among them. So we need to use all the information for some factors. For example, like those sun or clothing, probably there's something common. These features are common in a way to affect the comfort level and temperature prediction. However, we also want to learn the difference. So the approach we are taking, we try several one, and this is the one we finally find out is the best approach. Is first we train a neural network, use all the data in an undifferentiated way. The inputs, including all the variables we can measure, also include the demographic information of the driver. So you can think about this is just an overall model, like the base model. And secondly, when we have the base model, for each of the driver, we try different strategy to fine-tune the model using only the individual's data. And turns out that just fine-tuning the final layer of the neural network for each person is going to get the best results as good as you basically fine-tune everything, and it's much faster to converge if we only fine-tune the last layer. So how does it look like? This is two models plus two baselines. Baselines basically is more like a rule-based or basically without a machine learning model. It's more like a rule-based or something directly measured from the car or let the people to adjust the car. So we don't call it a model, it's more like a baseline. And here we report MSE, the mean square errors on each of the model. So if we first start with the simulation data, we know that MSE, the lower is the better. So when what we found is that when we using a general model in the simulation data, the simulation is built based on our diagram, right? And then it does the decrease. And when we further build the personalized model on top of the non-personalized model, and then it gives us the best result, the MSE is 0.5 to 0.6. After we approve that, okay, personalized model seems to be a good candidate to moving forward, we propose a data collection protocol, and customer actually was able to conduct experiments in another country. Basically, they hire some tester as the driver, and then they are able to drive the car. And meanwhile, they will adjust the temperature. The adjustment is more like the ground truth. And in this case, you can see it's very interesting. So the non-personalized baseline, personalized baseline, they are pretty high, right? And when you have the non-personalized model, it actually decreases. And when you have the personalized model, it's further decreased to 18. One question you may have is that, oh, why the real life data MSE is always higher than the simulation data? This is as expected, right? Because in the simulation data, we only define several factors or features we just talked about, right? The real world data, you can think about it. It actually showed that our thinking model is in the correct direction. However, there are some latent factors we are probably are not included in our simulation design. So but this is proof of concept. But in the future, when we have hypotheses, we can add those data or those features to evaluate, okay, whether that's an important feature we missed in our simulation.
Here's one question on the Q&A. Ankush asked how you measure the near skin temperature. Are you using like wearable a smartwatch or something? How did you measure those?
Yeah, so that's a very good question. So for the car, right? So in the proposal, we do propose based on some literature and also some physical model based paper, we do propose to have sensors, basically temperature sensors in multiple places for each near the driver and near the a little bit far and so on. In this case, the near skin temperature basically is decided by other factors. We could only get an estimate from the sensor close to the driver. Does this make sense? Yeah.
Yeah. And I have a question that for your model, what is then the target variable? Is it the like temperature that people adjusted or the number of times?
That's also a very good question. We consider both factors. I will show you how we consider the time in the next slide. So in the MSE, we basically using the adjust set temperature as the ground truth. So basically, if that person decrease 1 degree, right, and the model before that predict, okay, decrease 1 degree, or the difference between them is the MSE. Does this make sense? Yeah.
Yeah. And then there's another question from Ankush. You used the MSE for the evaluation. Did you use any other evaluation matrix and maybe consider that can be used in your case?
Yes. So let me go to the next slide. So what does it mean, right? We want to know that, okay, you see the decrease of the MSE. Does it really means that the driver feels more comfortable, right? So this is basically you can see we actually measure the comfort ratio. You can think about it more like for example, 70% of the time you feel comfortable. How we collect this? This is actually collect during the experiment. Think about it. You have something like a pad or a phone, and then the device that let the person to click on that, the feedbacks, yeah, in an interval like I cannot remember exactly, like every several minutes and so on. Does this make sense? So basically, take the human feedbacks about their comfort, hot and cold, and so on. Yeah. So you can see when we have the personalized model to control the temperature, the comfort ratio is increased about 15, yeah, about 15 or more than 15% compared to both the manual control by the person and also the general model. There's an interesting thing you can see when the manual control, the person can control by itself. It's actually, they will get the comfort ratio higher compared to they just have a general model that trained by all the data from different users. And however, when we fine-tune this model, it actually gives them the best comfort ratio measure during the experiment. Does this answer the question? I hope so.
Yeah, thank you.
Yeah, so so this is how we do proof of concept projects with a customer. You can see this SETA is just, you can think about this more like a SETA, a paradigm, so that the customer can basically replicate this to bring increasing knowledge and data, and even increase the complexity of the model to and further to improve the accuracy and the results. So this gives an example how we are doing the proof of concept and then deliver to the customer so that they can further to refine the model and then put into production. Yeah. So this is the first example. The next one is an example also very close to our daily life. So we know that let me explain to you why it's very close to our daily life. So we know that for a lot of financial organizations or insurance organizations, a lot of data remains in document, right? These are some example financial reports, even emails and invoices received, even like bank statement, wage statement, and so on. So a lot of those data actually are carried in documents, and it's not directly available for people to just run any analytics or to get the data directly. So normally what people do, what those companies do is that they hire people to extract those data manually. However, you can think about this is really time consuming and easy to get like human errors, and also very expensive nowadays. This is also very bad for financial companies because they do have the peak season, for example, like a tax season or like the SEC season, right? In those peak season, it's not easy to just scale the manual team, right? The label team suddenly like tenfold or sevenfold or so on. So this is actually not easy for them to scale in the peak season and then downscale when there's this non-peak season. Like you can, like you will guess and you will know that a lot of company actually already started using some rule-based system plus the human process. For example, you can use regular expression, right, to extract, for example, text from the 1040 and so on. And in those relatively consistent layout forms, they just create a lot of rules. For example, using regular expression to extract those fields they want, those entities, and then with the human tracker examiner to correct them and put that into the database. You can see this is rule-based model cannot be scaled very well when you have new type of documents or different layouts and so on. For each of those things, you need to repeat the process. And a lot of companies actually have the rule scripts longer and longer. It's very easy, and it's also very easy to break if the document have any changes. Let's see how this is a solution, basically machine learning solution. We working with AWS service team as well as the several customers, including Broadridge Financial Solutions, Black Knight, and Guardian's Life, to evaluate, to customize for each one, and then learn the common things, and then bring this as a repeatable solution that people can use. So what's the solution looks like? The solution is have two parts. You can think it's understandable if you started with a scanned document or an image, right? Then you have a receipt or something, you take a picture. In this case, first you need to have an OCR engine. In Amazon, you can use Amazon Tech Chat to extract the text. And then in the test, there are two steps. One is that if you is classification. Okay, you can tell, okay, this is the scan one, this image is a receipt, or this image is a invoice and so on. And after classify, and then we know that for each type of the document, what type of entities actually the company want, right? Or the user need. This is called entity recognition, which is in Amazon, we have a service called Comprehend. This is in this entity recognition model, they will extract from this page what's the name, account, and part number, and so on. And how do we think about this is that we realize that there are some a lot of documents, they have something in common. So that's why Amazon provides a pre-trained model to if you don't need a lot of machine learning information, you don't have label data, you can directly call those pre-trained model, right, which is trained on large amount data of different documents, and then to get some very commonly see entities like name and account. However, we know that machine learning customization is always the important part, right? Different document or even different company or even different subdomain of in the financial industry, they do have different requests and different document types. So in that case, it's very important that we could train the custom model or fine-tune the model, neither retrain or neither fine-tune. And in this case, we do need to have some data. So what Amazon, when we started to build this with the customer, we went through the process, and then later on, we make it this like a tool for customers can do that just by themselves. I want to give you an example. This example is very typical of machine learning training process. You can see, for example, this customer, they actually, I'm not going to do any documents. They actually have the support chat dialogue, for example, oh, my name is blah, blah, blah. And there's an agent basically help to reply to them. So they have this log, but the company wants to automatically extract the entity type, which is not name or something. They want to know, okay, what's the part number for each request, and what's the action the person, the agent actually do. So their entity type is basically different, right? And in this case, we need to have the data, something like this, as well as the original text. Basically, it's like a annotation, right? Labeling data. And then fine-tune the general model. In this case, we just need very small example for each of that new entity type. And then after that, after the training, then we can use the custom model to predict for the customized use case. So this is how we support each different company for their different use cases. Here is another example that, so you know, this is the mortgage statement, right? Also like bank statements, you can see, this is very commonly seen type of documents in financial industries, that it's a semi-structured document. It has some paragraph, and also it has some tables or some kind of structure, if like semi-tables or the just some columns and so on. So when we are working with, for example, Broadridge on this, the way we tackle this is that we say, okay, we could we introduce the positioning and structure features in addition to the test, to the model, right? The model, and then to train the model. In that case, it actually improve the result because it use not only the text information, but also use those structural information that machine can learn from the common characteristics, and then better to serve for things like PDF or like certain kind of semi-structural documents like Word sometimes and so on. So this is how basically further customize to the solution that for some companies that have very specific different layouts, but they are semi-structured and very different semi-structured layouts documents. So how does it work? So with this solution, actually we have been working with several customers along the past a year or two to deal with different type of documents and different formats. And we are able to help them to deploy the model into their pipeline, into their operations, so that they can automatically process millions of documents. And like you can see, this is a great thing for their peak season because they do not need to plan ahead to hire more people part-time during that season. They actually just need to scale out, right? If this is a model, right? They just need to scale out the inferencing capability of the model, or even spin more models to basically support their needs. So they can easily scale up and scale down with a model. Yeah. So one question you may ask is about the accuracy, right? So different industry or different sub-industry, they do have different requirement of the accuracy. So once you pass the accuracy, basically it's basically considered like comparable to human level. Then that documents, you don't need to have a human review. This is another thing good about machine learning model. When we do the prediction, we always can give them a lot of model, right? You can think of a deep learning model or even like a classic machine learning model. It also gives you the confidence score. You make this prediction so that the human checkers, they just need to check those things less confident, or those parts or those entities we know that it's not easy to predict correctly. So in that way, they actually reduce the human labels and make this faster. Yeah. Okay, so this is my last slide. I see there are maybe 2 questions. Yeah, I want to pause here.
So Lakshmi asked that financial document generally needs a high accuracy. Then could your model achieve that? I think you mentioned about the human reviewer too. So how does that work?
Yeah. So this is actually a great question. So really depends on the document type, right? Some needs really high accuracy. So this is the thing is that we do have the checker, but the checker does not need to review all those fields. Different company may use different strategies, like I just mentioned, right? One is that some company may have another automatic check or using the confidence score or more than one model to calculate the confidence, and some document can be passed. Only those documents with the confidence score lower than certain threshold will go to a human review. That's one thing. And second, a commonly used strategy is that basically some company also just, for example, that if they need to track 100 entities, they probably will select the most difficult based on the experiment results, right? And then just check those fields for each of the document and conclude about the accuracy for those each document, because each document have various layout. Like you can think about like a bank statement, right? Different bank have different layout. Even checking account and saving account statements could have different layout in the same bank. So this is some of the strategies people do here.
Last question that Charu has is that he also shared his experience working on the similar problem, but how did you include hierarchical information into the semi-structured or unstructured documents?
This is actually a great question. We develop a method to hierarchically extract some documents. This is not a good example, but you can think about, for example, there's some example like a proxy cards, right? We work with Broadridge Financial on the proxy card. Basically, it's like a voting card. And that is very important for each vote and to which entity. Basically, there's a hierarchy. So we do develop some methods, that we are putting that into a publication. So maybe after we publish, I can share more about that. Yeah.
Thank you. I have a small request that if you can do, I think as an alum, we're so proud that our alum is giving a talk and you are such a great role model. We have 87 students here, and maybe could you share about your experience for your career search and maybe perhaps some advice for the students or the alumni who are in our early career?
Yeah, I think before I want to first conclude my talk with 1 to 2 sentences before I go to that. Yeah. So you can think, so I used to work in the product team. Right now, I switched to more customer facing team. And the reason is that there are many reasons, but I want to say how I think about that. I think it's very important, right? We are always tracing the state of art in machine learning. It's still very important because that will actually affect the production, right, model. But on the other side, I think it's more like a parallel. There are quite a lot of effort people have been put into how to put the machine learning into practical, right? It could be production, it could be some other way to use that. So basically, it's about the state of art or the state of the possible or the state of the practical. I think they are very dependent on each other and are all very important. Yeah. So, to Dan's question, I'm so happy that I have been studying in the same program almost 5 years ago, and it's a great experience. So this is a broad question, but what I think is the most important is that number one is that you need to follow your interest, because nowadays, even in the data science program or the data science job family, you can see where there's already diverge into different sub roles in the data science, right? You can think about, for example, like a machine learning scientist, and machine learning engineer, and also have more analytics focused data science. They also use some machine learning, but they do not need to go to very deep level or think about the architecture that much. I think there are different type of roles, and you need to follow your heart to pick the direction. And of course, you can always adjust your path to another direction during the process. There's no like which role is better than the other, because we can see all the roles are based on the needs from those companies, right? So you need to think about what's the most interesting for you, and then you can develop your career there. I think this is something from the last several years. You can see the data science field also go through a lot of change, right?
Yeah, totally agree. And there's another question. If you can share about your interview process as a applied scientist at Amazon, and also how to better prepare it, that'd be great.
Yeah, sure. So our team's hiring, and also many other teams in AWS AI, science teams are also hiring. So basically the AWS AI hiring is not slowed down. It's still like a lot. And I actually just went to a conference with some recruiters from AWS yesterday, and they told me that the July and August are actually the peak season for recruiting in AWS. So prepare yourself for that. And so what's the typical process to interview as a scientist? No matter you are data scientist, research scientist, applied scientist in AWS, we have roughly like 3 parts, but they are not like distinguished that well sometimes. The first one is the your knowledge. Normally we measure that, for example, machine learning, right? Your depth, your breadth, yeah. And they will ask you a lot of questions, or sometimes ask you to decide use case and so on. The second part is very unique to AWS and Amazon, is the behavior questions. If you are going to interview with Amazon, you probably want to search for those behavior questions. They are all online. So behavior question is a very unique culture. I think in Amazon, you probably will have several rounds of that combined with the technical questions. And if you have a lot of experience about projects, internship, that's great. Just make sure to prepare a diversity of examples, and because we don't want to use one project again. And the last part is only for applied scientists, is the coding bar, SDE coding bar. So this is an interesting conversation with the recruiter, because some recruiter mentioned that some other companies, they do not have the job title called applied scientist, but Amazon has. So that's why a lot of people, they feel like, oh, I'm a data scientist, but I don't think I'm an applied scientist. But that's not true a lot of time, because you are coding, right? You code in Python and you know the data structure algorithm. So the only difference between applied scientist and research scientist, data scientist in Amazon, is that applied scientist needs to pass the SDE1 bar. So basically you can search SDE1, the entry level SDE. So they will ask you the question to code in the whiteboard, and the question normally related to data structure and so on. Yeah.
A question from Charo. What was something you didn't learn in the program? I bet there are so many, but later you found out it was very crucial.
So from my first industry job until now, most of the time I'm working on natural language processing. And this is, our program have the, I think the elective courses, right, in the last quarter. And I did take the NLP course, but however, I didn't have much opportunity during the program. For example, doing a lot of projects in NLP or doing an internship in NLP. So that's something I feel like if I know I will go to this route, I probably will go to a practicum in NLP and do more NLP projects. Yeah.
That's a good comment. Yeah, thank you so much for your time. And it was my pleasure to have you back and then give a talk to our students and also the other data scientists in the Bay Area and then outside of the Bay Area as well. Thank you so much for your time, Jennifer.
Thank you, everyone. Just want to mention, if you search the LinkedIn for my name, Jennifer Zhu, maybe at AWS or Amazon, if you want to connect, feel free to reach out to me if you are interested in any opportunities. We are hiring both interns this summer as well as full-times, a lot of full-times in my team and in other AWS AI team. Feel free to reach out if you are interested. Yeah.
I bet so many will reach out to you. Thank you so much for sharing that.
Thank you. Thank you.
Thank you.
Thank you,
Bye.
everyone. Good luck.